Hello everyone. In this session we are going to study about plasticity chart. It is nothing but a tool to classify fine-grained soils. Repeat, plasticity chart helps in classifying the fine-grained soils. Now we'll see the details. Suppose we want to classify 1000 grams of soil sample that we have brought from a field, right? So first step in classification is to sieve it through 75 micron sieve. Once you sieve it, then let us say around 400 grams of the soil is left on top of it, and then 600 grams of soil has passed through. Then you know that the soil which is retained above will be referred to as coarse fraction, which is less than half of the soil now in this case, because we have taken 1000 grams of that. 400 grams is left on top and then 600 grams has gone through. That is to say, more than 50% of the soil has passed through, and the soil fraction which is passed through is known as fine fraction. The soil part which is above will be referred to as coarse fraction. Fraction means it is part, coarse part and fine part. There are two parts. Okay, here as comparison tells, more than half of the soil is lesser than the size of 75 microns, then the whole soil, that is whatever soil that we have brought from a particular site, then the whole soil is classified as fine-grained soils. Now in that fine-grained soils, what we have, that is to say, it can be clay or silt, because in fine-grained soils we have names like clay and silt represented by C, and silt is represented by M. So either it can be C or it can be M, that is silt or clay. Now what you have to do is you have to take this soil sample and then sieve the soil through 425 microns, right? The soil which is passing through 425 microns will be taken for the whatever passing through 425 microns will be taken for determination of Atterberg limits. So right from the beginning, if you look at, when a soil sample is taken, it is sieved through 75 microns. We judge that it is fine-grained soil. Though we have judged it just fine-grained soils, of that you have to take 425 microns passing through soil, and then it will be used for finding out Atterberg limits. Atterberg limits are liquid limit, plastic limit and shrinkage limit. That we have studied in length. We have to find out all of them, and using that information we have to refer to what is known as plasticity chart for classification of the soil. Means what exactly, whether it is clay or silt, that can be judged, or even more than that information will be available in plasticity chart. Okay, so what is plasticity chart? It is a chart something like this. Okay, we'll go into the details of each one of them. This is a ready-made graph. Okay, so this graph will be a ready-made graph, means you should be able to reproduce it as it is. There are so many lines, one inclined line, there are two vertical lines, there is something plotted on x-axis, y-axis, etc. that we'll be seeing in detail over here. But anyway, you will not be having any data to plot it, but it is a ready-made graph. So plasticity chart is nothing but a ready-made graph. Now this is a graph IP on y-axis and liquid limit on x-axis. You can just see here, plasticity index IP, the plasticity index is plotted on y-axis and liquid limit is plotted on x-axis. Okay, the third point, there are two vertical lines at WL is equal to 35% and then 50%. You can just see these vertical red lines, WL equal to 35 and WL is equal to 50. There are two vertical lines. So these are the main features or salient features of the plasticity chart. Then the fourth point, there is an inclined, it should have been an inclined A line given by IP equal to 0.73 WL minus 20. Here it is shown an inclined line. It's called as A line and IP is equal to 0.73 WL minus 20. Right? Now if you substitute IP equal to 0, you will get WL equal to 20. That's why this point or this line passes through exactly 20, WL equal to 20 value, right? And then it is inclined with a slope of 0.73. Now the region above A line is of clay. Okay, here with respect to this line, if you look at here, C here, C here, C here, C there, so all that is clay. And then below, if you look at here, there is M, means the region above A line is for clay, the region below A line is for silt. Okay, then it can be Cl, Ci or Ch. Okay, so here you can see that it is Cl, here it can be Ci, here it can be Ch. What is the meaning of that? Now this is clay with a low compressibility, this is clay with intermediate compressibility, and this is clay with high compressibility. How do you judge that? Above A line is fine, and then on the left hand side of WL equal to 35 means liquid limit, if it is less than 35%, then the soil is classified as clay with low compressibility. If it is in this region, that is liquid limit in between 35 and 50, then this region will be meant for clay with intermediate compressibility, and above A line and on the right hand side of WL equal to 50, this is the region which is meant for clay with high compressibility. Okay, now next point, the region below A line is silt or organic soil. It can be ML, MI, MH. The same explanation. L stands for low compressibility, I stands for intermediate compressibility, H stands for high compressibility, and anyway M is for silt. So depending upon whether WL is less than 35 or WL is between 35 and 50, you can know this two vertical lines. And then beyond this, so in this region it is ML, silt with low compressibility. In this region it is MI, silt with intermediate compressibility. In this region it is MH, that is silt with high compressibility. Or also the region below A line is of silt or organic soil, means these are the regions also for organic soil in the same manner, that is less than 35, liquid limit less than 35, it is OL, organic soil with low compressibility. Again between 35 and 50, it is organic soil with intermediate compressibility, and then beyond this 50, if it goes, then it will be organic soil with high compressibility. Okay, now the soils having IP between 4 and 7, you can just see here IP between 4 and 7, and above A line, that is hatched area, that is liquid limit is more than 10, and then up to this A line, in that it is classified as CLML because it shows both the properties of clay as well as silt. That's why there is a dual symbol. Okay, now how exactly to use this is salient feature of the plasticity chart. Now how exactly it is used? Now what is done is, once the soil is taken for Utterberg limits, you will be able to find out WL and WP, that is liquid limit and plastic limit. Okay. Now once you find the value of liquid limit and plastic limit, let us say in this case there is an example taken represented by point B. Let us say WL liquid limit is, let us say it is, in this case they have taken 45%, so let me write that it is 45%, so 45%, and then the IP is of the order of 25 approximately. So plasticity index is given to be equal to 25%. Now what is IP? IP is nothing but WL minus WP. WL is 45 minus 25 means WP, that is plastic limit, is of the order of, let us say it is 20, so to say. So because of that, because of this two information, I'll be able to calculate IP, which is the difference of these two, 25. Then for 25 of IP and liquid limit of 45, I'll plot a point, and this point B falls in the region of what? In the region of CI. That's why the soil is classified as clay with intermediate compressibility. So when you conduct, because in earlier slide I have told you that you have to, once you recognize that it is a fine grained soils, you have to sieve it through 425 microns, conduct these three tests, and then refer to plasticity chart. So from this you will be able to get WL and WP. Then you come here, using WL, WP, calculate IP, mark the point on a ready-made chart. Depending upon the region in which the soil falls, the classification will be. Suppose by chance another point somewhere here it falls. Let us say this point is, say, point A. Now this soil will be now clay with high compressibility. Now suppose it falls over here, point C. Now this will be either silt with high compressibility, or it can be organic soil with high compressibility. Okay. Now that is what the meaning of the plasticity chart is, right? This point is C. Then it can be organic soil with high compressibility or silt with high compressibility. That's how you can recognize. Now the same thing is put in IS table, Indian Standard Table. So what is written here is fine grained soils. How do you recognize? It is said that more than half of the soil, half of the material is smaller than 75 micron sieve. Then it is fine grained soil, that is to say either it is a clay or a silt or organic soil. Now ML, CL, OL, you have seen that. L stands for low compressibility. So silts and clays with low compressibilities are represented as ML, CL, OL, and then here liquid limit is less than 35%. Then if it has to be represented by MI, CI, OI, then it is silts or clays with medium compressibility or intermediate compressibility, where liquid limit is between 35 and 50. Then MH, CH, OH, that is silts and clays with high compressibility, when liquid limit is more than 50%. On the chart also we have seen that the same information is written over here. If it is highly organic soil, then it will be recognized with its color and odor, and it will be represented by peat. Right? Now field identification, we will have a separate discussion. Just have a look, that's all. Now how exactly dry strength, dilatancy, toughness is done, we'll be discussing in separate session. Okay, thank you. Stop here.